Hello everyone. So in this lecture we'll understand what is in phase voltage and out of phase voltage. So in a simple way we can say when the two voltage reach their maximum, minimum and zero values at the same time, they are called in phase. If we consider these two waveform of voltages, so their minimum value, maximum value and the zero values are in same time. So that's why this is called in phase voltage. Phase angle difference is 0. Then waveform rise and fall together. This is the condition for in phase voltage. Now we will understand out of phase voltage. So this is completely opposite to that in phase voltages. Means here when the two voltage do not reach their maximum, minimum or zero values at the same instant, they are called out of phase. From this waveform we will understand this out of phase. So this is first waveform. This is the another waveform. So this is VB and this is VA 0 and this is pi, this is 2 pi. So we can say this waveform VA is start from 0, and if we see the second waveform, that VB, it's start from some non-zero value. So that's why there is a phase difference between these two voltages. Phase difference not equal to 0. So that could be 30 degree, 80 degree, 90 degree, like this. So this is called out of phase voltages. Now we will understand these two in phase and out of phase voltage with two example. So to understand these in phase and out of phase, we will consider three circuit. One is resistive circuit, another one is purely capacitive circuit, third one is purely inductive circuit. For in phase, we will consider purely resistive circuit. Okay, first we'll draw the circuit. So that is consider one resistance and one voltage source, one AC voltage source. So there is one voltage source and one resistor. So this is V is equal to Vm sin omega t, and this is the resistance R, current I. So first we will draw the waveform for this circuit. First we will draw the waveform. Okay, this is time period. So if we consider, so this is 0 and this is pi, this is 2 pi. Now we'll draw the waveform. So we'll draw the waveform for the current and voltage. So first we'll draw the waveform for the current. This is the waveform for the current. Now, so because of that resistance, so there will be some voltage drop, and we are considering that voltage drop magnitude is little bit higher than that current, so that we can draw like this. So this is the current, this is the voltage waveform, this is the voltage, and this is the current waveform. So from this waveform we can say that its minimum, maximum values and zero values are at the same time. So that's why both is in same phase, both voltage and current is in same phase. Now we'll draw the phasor diagram for this. If we take current as a reference, this is the current. Now we'll draw the phasor diagram for the drop across this resistance. So that is in phase, same phase. So this is VR. So we can say for the purely resistive circuit, so that voltage and current both is in phase. Now we'll see the example for out of phase by using two circuit. One is purely capacitive circuit, and purely inductive circuit. In purely capacitive circuit, current waveform, current leads the voltage by 90 degree. Now we'll see the waveform. So if we draw the waveform, suppose this is pi, this is 2 pi, so this is pi, this is 2 pi. So this Vc t we can write Vm sine omega t, sine omega t, and V, sorry, and Ic t can be written as Im sine omega t plus 90 degree, omega t plus 90. So from these two equations we can easily draw the waveform. So first we'll draw the waveform for the voltage. So that is, so this is the voltage waveform. So for that, if we consider this is 90 degree, so we can draw like this. Okay, this is the current waveform. This is the voltage waveform, and this is the current waveform. Current waveform is leading by 90 degree, so that is it leads by 90 degree. So if we represent this in a phasor diagram, then it will be like this. If this will be Vc and this will be Ic, so that is that phase difference between that voltage and current is 90 degree. Now in case of a purely inductive circuit, inductive load, for that purely inductive circuit of a purely inductive load, current lags the voltage by 90 degree. Now the waveform will be completely reversed. Now if we draw the waveform, so so there is two waveforms. So this is for the current waveform, and this is voltage waveform. So where that current is voltage is leads the current by 90 degree, or current is like the voltage by 90 degree. It is 0, 90, is pi, is 2 pi. Now if we draw the phasor diagram for this, it will be like this. This is IL and this is VL. Now here voltage is leads the current by 90 degree, or current is like the voltage by 90 degree. So this these two, so that is these purely inductive and purely capacitive circuits are the example of out of phase, and resistive circuit is the example of in phase voltage. Thank you.